Carol Hollingsworth, the JPS Vice President of Sales. I'm with Iggy Bragato, the JPS Senior Sales Engineer today. Iggy will provide you with today's presentation. We really appreciate your joining us today. This is our first monthly product briefing in 2021. We have plans to provide a different product briefing each month. Each of our monthly product briefings are planned for a brief 45 minutes. Today, Iggy will discuss the ACU-Z1, the next generation interoperability gateway. This brief webcast is an introduction of the ACU-Z1 Interoperability Gateway. Iggy's discussion of ACU-Z1 will cover wide area interoperability with a more modern approach to providing wide area coverage. The presentation will illustrate the key features of the ACU-Z1, including ease of configuration, usability, and user-friendly graphical user interface. We will record each of the monthly product briefings as we have in the past. These recorded JPS product videos are available to you. We're hopeful of being able to return to meeting with you face-to-face sooner than later. However, for the time being, we will continue to provide short, informative, monthly product briefing webcasts to you. We truly appreciate your being with us today. Now let's get to the real reason you're here. Let me introduce Iggy Bragato. Iggy, thank you.
Okay, hey Carol, thank you. Appreciate it again. And I'd like to welcome everybody 2021 to our first JPS Interoperability Solutions monthly product briefing webcast. I'm Iggy Bragato, Senior Sales Engineer, and it's always nice to have with us Carol Hollingsworth, our VP of Sales. And so in this week's webcast, we're going to have a brief introduction of our next generation interoperability gateway, and that would be the ACU-Z1. And the ACU-Z1 is our fourth addition to the line of Z family of products, and that started with the RSB-Z2 dual channel gateway, as you can see in the center, and the Z2 controller at the left, and the MCC multi-channel console. So check our previous webcast on our website if you would like to learn more about these newer Z products. And so the ACU-Z1 is very similar to our other high capacity interoperability gateways, whether it's the modular ACU-2000 you see in the center, or the non-modular ACU-5000 at the top, the 1RU unit. And they all have 12 channels in a single channel, in a single chassis. And so the interface modules at the right of the two modular chassis, and that would be the ACU-2000 or the newer ACU-Z1, they can be populated specifically to meet the needs of your mission. The ACU-5000 can be purchased with integral channels ranging from 4 channels to 12 channels. And although the ACU-5000 doesn't have discrete modules, its integral channel types would be changed at any time on the fly. So it's just as flexible as the ACU-2000, and really maybe even more so in terms of its channel types and flexibility. And so interfaces are able to support land mobile radio networks, standards-based protocols such as SIP or RTP, as well as analog switch telephone networks, JPS ROIP, which is our radio over internet protocol. And we can even support local operators' handsets. And all of our land mobile radio interfaces employ purpose-engineered digital signal processors that really help assist in the adjustment of audio gain levels in all our modules within the system to help mitigate the effects of being under-modulated or over-modulated. We also employ digital signal processors that have digital buffering, and this is also employed to prevent the loss of syllables or words at the beginning of a transmission. And these digital signal processors are also capable, in many cases, of detecting the presence of human speech in usually intrinsically noisy radio environments such as HF or single sideband environments, or even when using aviation-style radio systems. And remember, these digital signal processor algorithms are designed to work with land mobile radios. They have not been repurposed for anything other than land mobile radio communications. All of these gateways can naturally be controlled remotely over the network, and all platforms can operate between 115 volts and 230 volts AC or 12 volts DC nominal, which really makes these gateways really perfect candidates for fixed sites, tactical, and even vehicular applications. And all of these gateways are Waze compatible. And for those of you that aren't familiar with Waze, W-A-I-S, the Waze application, Waze is a client-based ACU controller application that can manage multiple ACU gateways that are distributed throughout a network environment. So as you can see, the blue rectangles represents network talk paths, and those talk paths allow us to share ROIP data with other ACU gateways within this interoperable environment. So in the case of the ACU-2000, the modular gateway, this would be represented by discrete and separate DSP2 modules located within that chassis of the ACU-2000. But in the case of the next generation ACU-Z1, Waze network talk paths are virtual. They're not physical modules. This will really not require, again, those physical hardware pieces. And so the ACU-Z1 will support up to 4 virtual Waze talk paths. And that's one of the unique attributes of the ACU-Z1 is that it includes many virtual interfaces, which we'll be talking about in a moment. And the purpose of that is really to reserve or preserve the physical modules within the chassis to support donor radios, which is probably really the most important part of interoperable or centralized gateway. And one of the more important aspects of the ACU-Z1, it can integrate with existing Waze systems. So we're really aware of many large Waze systems out there, and one that I know of is a system that contains 120 ACUs, ACU-2000s as well as ACU-5000 in a single system that has a total interface capacity of over 1,400 different channels, which is pretty astounding. And so the ACU-Z1 is really a perfect candidate for those existing Waze systems. And that's pretty much where really the similarities end between these different gateways, and really the uniqueness of the new Z architecture really makes this new ACU-Z1 kind of an interesting addition to our line of interoperable gateways. So let's talk about some of the modules very quickly here. And one of the more important modules, obviously, is a PSM power supply module. It's a discrete module. It's just like our other power supply modules within our modular gateways. And it's used to condition and distribute power to the rest of the modules in the chassis. And the ACU-Z1, as we mentioned earlier, can be powered either by AC or DC current, where AC input is the primary, and will automatically switch to DC sources upon loss of AC current. So again, you can run both AC and DC at the same time. The CPM-Z1 module is our most powerful processor to date, and it contains a quad-core 1 gigahertz processor that really provides our system control and management, and it also serves a secure web browser user interface, which we'll be looking at in a moment. And we'll have some upcoming webcasts that will actually tour the user interface in much more detail. What's really nice about the browser-based user interface is that you will not need client-based controller software to manage the system. The user interface is now browser-based, which means most standard browsers can be used really on a myriad of different platforms, PCs, Macs, even smartphones. So you might also have noticed that the ACU-Z1 does not have a separate HSP module that you would typically see in an ACU-1000 or an ACU-2000. And this has now been integrated directly into the control processor module itself. And additionally, a USB port on the control processor module helps us integrate a Plantronic wireless headset, which is represented as a completely separate resource in the user interface, and while still retaining the full functionality of the traditional push-to-talk handset all at the same time. So you can operate the traditional PTT handset and the wireless headset all at the same time. And with the native 12 channels, the physical channels in the chassis itself, add in the PTT handset, add in the wireless headset, this chassis can support up to 12 physical channels. And, you know, this does not even include the 24 virtual channels, which we'll be talking about in a moment. And this essentially makes this single chassis a 38 channel gateway. You would need 3 ACU-2000s to equal that type of capacity, which is pretty unique with this ACU-Z1 chassis. A unique feature of the ACU-Z1 is the VIM, or voice interface module. I like calling it the VIM module. And when compared to purpose-specific modules that we often see in the ACU-1000 or the ACU-2000, the Vim module can perform multiple functions that would normally require many different modules. If we log into the ACU-Z1, and as I mentioned in our upcoming webcast, probably going to occur next month, we're going to really dive deep into the user interface. And so if we log into the ACU-Z1, we can address each of the VIM interfaces separately. We can also define the VIM interface by selecting its type. And in the future, you'll notice that the types menu will probably grow as we add other digital interfaces. And you might see some of these types disappear as we begin to virtualize some of these interfaces. What's nice about the quad-core processor that's in the control processor module, we have really lots of room to grow in the future and add these really unique functions and features. So while we're in the settings page, you can see at the left of the panel the local resources. There are 12 resource icons that represent the physical VIM and PSTN modules within the ACU-Z1 chassis. And you might notice that there's a 13th resource icon, and that represents the PTT handset. And so if we plug in the base or the dongle of a Plantronics wireless headset, we will see the 14th resource icon listed under the local resource panel. Below the local resource panel are the remote resources. And remember, there can be up to 24 virtual or remote resources. And in this example, we're only using 10 of the remote assets. And those are ranging from radio talk groups. Those are some links to a Waze system. We also have a SIP voice extension and even a couple channels of an MCC4 multi-channel console. Again, these are virtual channels. These are not physical channels. In continuing, with our effort to try and conserve the hardware within this chassis, there are several types that are designated pass-through, and hopefully you can see that in the menu below. And these pass-through types help conserve the hardware and dedicate the interfaces to directly support attached donor radios and support those radio talk groups, which is really exactly what you want to do with those interfaces. Reserve those physical interfaces for donor radios. So the pass-through does exactly what its name suggests. It passes radio traffic, transmit and receive traffic, to a digital protocol, such as JPS ROIP, SIP, RTP, even JPS via push talk over cellular, even ES-chat, and other protocols are soon coming. Not only can the radio talk group interact with the remote digital resources, it can also interact with the physical modules or virtual channels that are being represented by the ACU-Z1 Gateway itself. For some of you that are seasoned ACU-2000 or ACU-1000 users, it was always necessary to incorporate two DSP modules, two physical modules, to send radio communications or even telephony communications over a digital ROIP link over the network. And pass-through modes allows us to be more hardware efficient and use only a single module instead of the traditional two modules. So our attempts to conserve that hardware is part of this architecture. And so one of the VIM types is a radio interface type. And as you know, because of the radio-centric digital signal processors that we use, we've created a 100% agnostic radio interface. So with no regards to protocol, transmit and receive frequencies, or the modulation technique of that radio, we have a pure agnostic radio interface. So the specifications are very similar to our other gateways with receive sensitivity as low as -26 dBm. But we have also increased the transmit audio delay to 5 seconds of buffering. And we use the audio buffering to essentially mitigate the loss of the first syllables or words in the transmitted audio stream. 5 seconds of transmit audio delay means that the gateway is now really right at home with very process-intensive satellite-based communication systems or scrambled or encrypted radio systems. So 5 seconds is a welcome addition to dealing with these very unusual radio systems that we often see. Another user selectable type is SIP, SIP, or Session Initiation Protocol. And this is a standards-based protocol that allows the VIM module to register with a VoIP proxy server to allow inbound or outbound digital telephony calls to be established with any other communication resources associated with the gateway. And that not only includes the physical modules, we can also backhaul VoIP telephony calls over the network to other remote assets on the edge. So you don't necessarily need to be in an environment where there is VoIP or even a PSTN connection. You can do that all remotely. Another VIM type is ROIP, which is Radio over Internet Protocol. And this is the JPS ROIP protocol, which allows the ACU-Z1 to interact with other JPS gateways, whether they're new or existing in the field. We'll be coming out with more future webcasts that will showcase use cases that rely on the flexible nature of ROIP and how we can marry the Z architecture into existing systems. And this will help us really overcome a lot of communication obstacles. And so JPS ROIP protocol has been incorporated into other manufacturers' product, which is very interesting. So as coming up with solutions for your customers, there might be lots of opportunities to directly integrate our products and services with your customers' non-JPS equipment on a digital basis. Not only do the physical VIM modules support ROIP, again, there are up to 24 ROIP channels that you have on hand. And again, these are not physical, but these are virtual channels. And again, with the PTT handset and the wireless headset, again, you're looking at 38 channels in this single chassis. It's pretty unique. Another digital protocol in terms of a VIM type is RTP, or real-time transport protocol. And as most of you know, this is the same protocol used in SIP digital telephony, except it's a unicast stream that doesn't require the signaling that we normally see in a SIP type of protocol. So RTP is often used to stream radio or telephony communications to voice logging recorders or dispatch consoles. And because RTP is standards-based, there's a good chance that it is able to interact with your customers' existing communication systems or subsystems that are also RTP capable. eROIP isn't really a VIM type of a protocol, but it's an optional data encryption feature that is incorporated into bridge channels and ROIP types. So depending on the JPS equipment that you are considering, eROIP might be something to consider. So all our products that support bridge channels, which I will talk about in a moment, and some of those of the latest products that support JPS ROIP can now protect voice communications over the networks using protocols such as HC128 or AES-256 encryption. eROIP is a license option. You can even move the licensing keys to different network links as your mission changes. And so one unique attribute of JPS eROIP is it removes the dependencies of external influences such as third-party network timing protocol servers, DNS servers, or even certificate servers. And so this means that if there's a denial of service or an attack on those servers or networks, the ACU-Z1 can still self-support its own encrypted ROIP links. And those are, again, HC128 or AES-256 links. And this could be very important in a national emergency incident where networks or even the ACU environment might be working a stovepipe, does not have network connectivity. Really a unique attribute of JPS eROIP. Bridge channels, again, is not really a specific VIM type, but it's really an embedded function of the ACU-Z1. We're actually associating this to a system feature. It's an integral system function that is used to link remote communication sources to other communications sources, such as remote RSPZ2s or remote MCC multi-channel consoles over the network. And we'll see a couple examples here in a moment. Not only does it provide dynamic linking of resources, but it also has the ability to provide better remote resource management, more so than the standard JPS ROIP protocol. So this is an evolving transport protocol that really going to be the primary method of sharing radio and telephony voice information over the network within that Z architecture. The last VIM type I want to discuss is how we support push-to-talk over cellular services. Because many POC service providers implement JPS ROIP protocols within their architecture. Now, we thought it was only natural that we include those that are specific to JPS radio interfaces, because each POC service provider has different nuances to their provisioning. We've created specific setups for each. So depending upon the POC service provider, we've added and even removed unnecessary parameters that are used to simplify the setup of the Vim module with respect to the specific service providers. We have a list here. It's a very small subset of POC services that we currently support, and we're seeing more come on board. So this really helps the integration of your push-to-talk over cellular services into this new environment. Another new module is the PSTN-Z1 module, and because the PSTN is an analog switch circuit-based system, we actually had to develop a completely separate module for that purpose. It does also have the ability to link remotely, which is very unique in terms of what this PSTN module can provide for remote sources. So if I have an operation where I have an ACU-Z1 in an environment where it is connected to the PSTN network, I can have remote assets that are thousands of miles away that do not have analog telephony connectivity. Through a bridge channel, they can link back to the ACU-Z1 and use a telephone that's local to the ACU-Z1. A very unique module. And the ACU-Z1 can support up to 4 PSTN modules, and they must reside in slots 9 through 12. This is a view of the rear of the chassis. There are 4 RJ11 ports at the rear of the chassis that support these modules, again, in slots 9 through 12. So again, we can support 4 PSTN modules in the single ACU-Z1 channel. And because of the network-centric nature of the Vim modules and the PSTN modules, each are connected to the local network using an Ethernet switch, a very simple flat network. Advantages of this is that it becomes much easier to link assets in the ACU-Z1 with our not only local assets on the same chassis, but it makes it very dynamic, and we can link to other remote assets on different networks. We'll look at some of these examples in a moment, but the ability to segregate parts of the network is very flexible. You know, the Z1, we can also self-generate IP addresses for all the populated interface modules, and this is based upon the IP address of the control processor module. So we'll self-generate those IP addresses. You can even manually enter module IP addresses as well. And the ability to manually enter a specific IP address can be useful when linking assets using JPS ROIP over the network that must be isolated from the primary network. And this allows us to segregate portions of the network. And this might be really important when we're dealing with secure networks or specialized networks such as SATCOM networks. And one of the most important architectural features of the ACU-Z1, and for that matter, the entire line of Z family of products, are bridge channels. Just like JPS ROIP, JPS bridge channels are used to transport LMR and telephony voice communications to and from remote assets such as other ACU-Z1s or even RSP-Z2 gateways or even MCC multi-channel consoles. So in the future, we may see these links moving metadata back and forth, even pushing software updates to those devices at the edge. So really bridge channels kind of our future in terms of how we manipulate these devices. And so those of us have been versed in creating a JPS ROIP network links for almost 20 years. You know, for instance, using 2 NXU2 modules, one module being designated as a client, as you can see on the left, and the other module being designated as a server, as you see as a right. And, you know, we call this the client-server association model. This is a very robust self-healing network link where we can share LMR communications over any network, even the internet. In this case, we're able to implement a firewall at the server device, and in this case, the NXU2B at the right. That's in case we're implementing this over the internet. And because of the peer-to-peer architecture of our standard JPS ROIP, it can only support 2 endpoints. And redirecting the ROIP data from a different endpoint might sometimes be difficult, especially if a client endpoint is attempting to send ROIP data to another client endpoint. And remember, clients must connect to server endpoints, not client to client, must be client to a server. And so additionally, firewalls will need to be re-provisioned. And in many cases, network supporting the endpoints might not have the proper firewall or facilities to manage that network. So this is kind of perfect example for systems that are requiring LTE routers or even SATCOM routers. JPS ROIP is largely part of what we do, in terms of sharing radio or telephony voice communications over the network, really because of its reliability. It's very robust, it's self-healing, and it has low bandwidth requirements using GSM vocoders in many cases. But in some situations, especially in very large wide area deployments, JPS ROIP can sometimes be limiting. And many of our products support network multicast or internet group multicast protocol. Some agencies will not allow multicast traffic on their networks. And if you're implementing the internet, then multicast network traffic is not possible. Conversely, JPS Bridge Channels types of links are very much more dynamic in the presence of the ACU-Z1 or even a Z2 controller. And we've talked about that in other webcasts. So the endpoints do not necessarily require a firewall or port forwarding, which is really an advantage in tactical environments using LTE or SATCOM. Although we would prefer a firewall or the ability to port forward or look into those remote devices, they're not necessary. You do not need complicated networks out at the edge. And in the presence of the ACU-Z1, bridge channels allow endpoints to share communications even if they don't have a firewall, right? So the one-to-one or peer-to-peer association really is no longer a concern with bridge channels when they are implemented. You can have one user to multiple users or multiple users talking to a single user. The one-to-one or peer-to-peer association is no longer a concern with these bridge channels. And so the sharing of communications, doesn't even necessarily need to involve the ACU-Z1 gateway or its assets physically in the chassis. And in this example, the interoperability in this case is taking place with just the endpoints. So the architecture has greatly simplified network access requirements, particularly when dealing with the public internet, inability to implement multicast. So the links are still self-healing, they're very resilient and reliable, but are really much more flexible than the standard JPS ROIP. They both have their use cases and their place. And remember, you could always optionally encrypt these links with HC128 or AES-256. For integration with our other products, such as the ACU-2000s, ACU-5000s, even ACU-Ms or NXUs, the ACU-Z1 can also create bridge-like channel links with standard JPS ROIP interfaces. And this is really good news, as you'll be able to keep those existing gateways in the field. You'll have the convenience of the Z-Class browser user interface and that really very flexible architecture. These are the 24 virtual channels that I mentioned earlier. Bridge channels and ROIP channels can be assigned from this ACU-Z1 settings page. In addition to the 12 local or native channels of the physical gateway, again, you can introduce these 24 remote assets into that system for essentially a total of 36 interoperable channels. Again, add that PTT handset, add the wireless headset, and you have essentially 38 channel gateway. And as I mentioned earlier, you would need 3 ACU-2000s or 3 ACU-5000s to equal this type of capacity. Bridge and ROIP channels can also be assigned discrete unicast port values. The remote JPS gateway interfaces will be then delivering their ROIP or bridge channel data information, which is voice communications, to the ports of the ACU-Z1 through these designated ports. And this should match the port forwarding of the firewall supporting the ACU-Z1 if we're implementing the internet. And so by combining the use of bridge channels and the traditional JPS ROIP channels and adding the flexibility of the Z architecture, you can really create many hybrid solutions, tackle really any communication issue. As long as that network's in place, these issues can be solved. And also included those existing gateways into this new type of communication architecture. So in this example, all our interoperable products, even existing JPS gateways in the field, can be brought into this unique Z architecture. If you need to increase the capacity beyond 36 or 38 channels of the single ACU-Z1, you can always incorporate or add a Z2 controller to bump that capacity up to 80 communication resources. Or you can even interleave multiple ACU-Z1s or interleave multiple Z2 controllers to create these very large-scale interoperability domains. Great architecture. Check our website for more information. We're setting up demos as we speak, and if you're interested in doing something live, we'll be happy to do that. So again, I'd like to thank all of you for joining our webcast today, and if you need more information regarding the next generation interoperability gateway, you can always call us directly or visit our website at jpsinterop.com. So with that in mind, Carol, do you have something you want to close with?
Yes, thank you, Iggy. Thank you very much. We do encourage you to visit the JPS website, where you'll find detailed product information, including the ACU-Z1 and the other Z products. On the website, you can also locate your local sales rep, your local dealer, and our distributor tally under the sales banner of our website. Your JPS inside sales contact is Bonnie Harwood. You can contact Bonnie at JPS. Her number is on the website. It's underneath the sales contact. And please don't forget the JPS customer support hotline. It's available 24/7, and that number is 800-543-2540. And that too is on the website underneath the banner for support. This is the completion of this month's product briefing webcast. We truly appreciate your taking time from your busy schedule to join us and learn about the new JPS product, the ACU-Z1. Thank you so much again, and have a great day. Thank you.